Welcome to session number 4 of inverse trigonometric functions. In previous session, we have completed some problems of exercise 2 of inverse trigonometric function. Now, in this fourth session, we are going to complete the remaining problems of exercise 2 of inverse trigonometric function. Now, find the value of each of the following questions from 11th to 15th. 11th question is tan inverse of 2 cos of 2 into sin inverse of 1 by 2. Solution: given tan inverse of 2 into cos of 2 sin inverse of 1 by 2. So first of all, you calculate inside the bracket. First you calculate innermost bracket, that is 2 into sin inverse of 1 by 2. Tan inverse of 2 into cos of 2 into sin inverse of 1 by 2. In sin function, at which degree we got the value 1 by 2. So sin 30 1 by 2. Sin 30 1 by 2. In place of 1 by 2 you write sin 30. In place of 1 by 2 sin 30, that is 5 by 6. Tan inverse of 2 cos of 2 into sin inverse of sin theta. We got theta. Since we know the formula sin inverse of sin theta, that gives theta. Sin inverse gets cancelled. The remaining value is theta. Now sin inverse of sin theta, that is 5 by 6. Now 2 1s 2 3 gets cancelled. Tan inverse of 2 cos inverse of 5 by 3. Tan inverse of 2 into cos 5 by 3 cos 60 1 by 2. So 2 gets cancelled. The final answer is tan inverse of 1. So tan inverse of 1. Tan 45 1. So in place of 1 we can write tan 45. 5 by 4. Again tan inverse of tan theta gives us theta, that is 5 by 4. So final answer is 5 by 4. Now 12th question is tan of 1 by 2 into sin inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. Now solution is given tan of 1 by 2 into Sin inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. We know that the formula for sin inverse of 2x by 1 plus x square and cos inverse of 1 minus x square by 1 plus x square. We know the formula 2 into tan inverse of x equals to, in terms of sin inverse of 2x by 1 plus x square, and 2 into tan inverse of x equals to cos inverse of 1 minus x square by 1 plus x square. Already I am given the formulas. From that list I am writing 2 into tan inverse of x equals to sin inverse of 2x by 1 plus x square, and 2 into tan inverse of x equals to cos inverse of 1 minus x square by 1 plus x square. So once you observe here, sin inverse of 2x by 1 plus x square, in place of this term you can write 2 into tan inverse of x. Why? Because we are given 2 into tan inverse of x equals to sin inverse of 2x by 1 plus x square. Similarly, cos inverse of 1 minus y square by 1 plus y square gives us 2 into tan inverse of x. Both the formulas are same, but this formula is in terms of sin, this formula is in terms of cos. So tan of 1 by 2. So in this place you can write 2 into tan inverse of x plus, so this term, this cos angle value is in terms of y, so that gives 2 into tan inverse of y. Next step, tan of 1 by 2, take 2 as a common, 2 into tan inverse of x plus tan inverse of y. Now 2 gets cancelled, then tan inverse of x plus tan inverse of y is the remaining term. Now you observe here inside the bracket, it is in the form of tan inverse of x plus tan inverse of y, that gives tan inverse of x plus y by 1 minus x into y. So according to this formula, tan inverse of x plus tan inverse of y equals to tan inverse of x plus y by 1 minus xy. You can write here tan of tan inverse of x plus y by 1 minus x into y. Now tan of tan inverse of theta, that gives theta. Therefore tan inverse gets cancelled. The remaining value is x plus y by 1 minus x into y. This is the final answer. Next step, I am writing here 13th question. That's simple question. 13th one. Cot of tan inverse of A plus cot inverse of A. Find the value of cot of tan inverse of A plus cot inverse of A. So solution given cot of tan inverse of A plus cot inverse of A. We know that tan inverse of x plus cot inverse of x, that equals to pi by 2. Tan inverse of x plus cot inverse of x, both the angles are equal, and tan and cots are inverse trigonometric functions. Then you can write that particular condition, that is pi by 2. So tan inverse of A plus cot inverse of A gives us pi by 2. So the total answer is cot of pi by 2. That is cot 90, pi by 2 means 90, cot 90 is 0. So 0 is the final answer. Next, 14th question. Very important question. 2 mark question. If sine inverse of 1 by 5 plus cos inverse of x that equals to 1, sine inverse of 1 by 5 plus cos inverse of x that equals to 1, then find the value of x. So our aim is here to find the value of x. Solution: given sine inverse of 1 by 5 plus cos inverse of x that equals to 1. Now you shift this value, sine value, to the RHS part, then it becomes sine inverse of 1 by 5 plus cos inverse of x that equals to sine inverse of 1. Now sine inverse of 1 by 5 plus cos inverse of x that equals to sine inverse of, what is the value of 1 in sine function? Sine 90, 1. So you can write in place of 1, that is sine 90, pi by 2. Now sine inverse of 1 by 5 plus cos inverse of x that equals to sine inverse of sine theta, that is theta. Now sine inverse of 1 by 5 equals to pi by 2 minus cos inverse of x. Shift this value to RHS part. Next one. We know that in sine and cos function complementary angle, sine inverse of x plus cos inverse of x equals to pi by 2. This is one relation. Sine inverse of x plus cos inverse of x equals to pi by 2. So in place of pi by 2, you can write sine inverse of x plus cos inverse of x. Sine inverse of 1 by pi that equals to sine inverse of x plus cos inverse of x, in place of pi by 2 sine inverse of x plus cos inverse of x, according to this formula, minus cos inverse of x. Now negative cos inverse of x, positive cos inverse of x gets cancelled. Sine inverse of 1 by 5 equals to sine inverse of x. Both the values of sine inverse functions are equal. When it is occurred is when those two angles are equal. If the angles are equal, then the values of that particular function is equal. Therefore x equals to 1 by 5. This is the value of x. Next, 15th question. If tan inverse of x minus 1 by x minus 2 plus tan inverse of x plus 1 by x plus 2 that equals to pi by 4, then find the value of x. Then find the value of x. Solution: given tan inverse of x minus 1 by x minus 2 plus tan inverse of x plus 1 by x plus 2 that equals to pi by 4. We know the formula, that is tan inverse of, since tan inverse of x plus tan inverse of y that equals to tan inverse of x plus y by 1 minus x into y. So the given expression is in the form of tan inverse of x plus tan inverse of y. Tan inverse of x, this total angle is x, this total angle is y. Then you can write tan inverse of x plus y by 1 minus x into y. So according to this formula, tan inverse of x minus 1 by x minus 2 plus x plus 1 by x plus 2 by 1 minus x minus 1 by x minus 2 into x plus 1 by x plus 2. Tan inverse of x plus y by 1 minus x into y. Now I am writing here that equals to tan inverse of in numerator part you can take a LCM, that is that equals to total value is pi by 4. Now x minus 1 into x plus 2 plus x plus 1 into x minus 2 by x minus 2 into x plus 2. In denominator part, x minus 2 into x plus 2 minus x minus 1 into x plus 1 by x minus 2 x plus 2. Now that equals to pi by 4. That equals to tan inverse of, in numerator part, multiply those two brackets, x into x, x square plus 2x minus x minus 2 plus x square, x into x square, x into 2x minus 2x, 1 into x plus x, 1 into 2 minus 2 by x square minus 4, a plus b into a minus b. Now in denominator, x square minus 4, here minus of x square minus of minus plus 1 by x square minus 4. X square minus 4, x square minus 4 gets cancelled. Positive 2x, negative 2x. Next, positive x, negative x gets cancelled. X square plus x square, 2x square, tan inverse of 2x square minus minus 2 minus 2 minus 4 by x square gets cancelled, minus 4 plus 1 minus 3, that equals to pi by 4. Okay, next tan inverse of 2x square minus 4 by minus 3 equals to minus pi by 4. 2x square minus 4 by minus 3, that equals to pi by 4. Now we transport this tan inverse value to RHS part. Then it becomes 2x square minus 4 by minus 3 equals to tan of 5 by 4. Now 2x square minus 4 by minus 3 equals to tan 45, that is 1 now. Take cross multiplication, minus 3, 2x square equals to minus 3 plus 4, 2x square equals to 1, x square equals to 1 by 2. So x equals to plus or minus 1 by root 2. This is the value of x. Next, sixteenth question. Sine inverse of sine 2 pi by 3. Solution. Given sine inverse of sine 2 pi by 3, that equals to, actually once you observe here, sine inverse of sine theta gives us sine inverse of sine theta, that gives us theta. If you apply this formula here, then you will get sine inverse of sine theta, that is 2 pi by 3. Directly we will get this answer, 2 pi by 3. Now here the given function is sine function. So this theta should be in the range of sine function, that is 5 by 2 to 5 by 2. 5 by 2 to 5 by 2. But 2 pi by 3, this theta is more than 90. 2 pi by 3 means 120 degrees. 120 degrees is not in the range of this sine function. So we calculate in another way. Sine inverse of sine 5 minus 5 by 3. You split this 2 pi by 3 into 5 minus 5 by 3. If you take LCM, then you will get the previous function only. So that equals to sine inverse of sine pi by 3. Since sine pi minus theta, that equals to theta, sine theta, sine pi minus theta equals to sine theta. Pi minus theta is in the second quadrant. In second quadrant, sine value is positive, so sine pi minus theta equals to sine theta. That equals to, now you apply this formula, sine inverse of sine theta equals to theta. That equals to pi by 3. This is the answer. 17th question. So 17th question is similar to 16th question. So I am going to 18th question. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. So you observe here, if this total bracket is in terms of tan or cot, then you can apply the formula. Here we don't have any formula for applying for this question. So you convert this sine function and cot function in terms of tan function. Solution given tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. So I am drawing one right angle triangle here, triangle ABC. I am taking theta here. Now we take sin inverse of root 3 by 2, sin inverse of 3 by 5, that equals to theta. Sin inverse of 3 by 5, assume that is theta. Then sin theta equals to 3 by 5. What is the value of sin theta? Sin opposite side by hypotenuse. So opposite side is 3, hypotenuse 5. Then automatically adjacent side is 4. If you apply the Pythagoras, then you will get adjacent side is 4. From this, you calculate the value of tan function. So tan theta equals to opposite side by adjacent side, that is 3 by 4. Then theta equals to tan inverse of 3 by 4. So both the theta values are equal. Sin inverse of 3 by 5 equals theta. Tan inverse of 3 by 4 equals to theta. Theta equals to theta. Then sin inverse 3 by 5 equals to tan inverse of 3 by 4. Now write here in place of sin inverse of 3 by 5, that is tan inverse of 3 by 4. So tan inverse of 3 by 4 plus cot. Cot is the reciprocal of tan. So you take here tan of cot of 3 by 2. But you take here 2 by 3 tan of. Simple. Now you apply the formula tan inverse of x plus tan inverse of y. That is tan inverse of x plus y by 1 minus x into y. We know the formula, that is, since tan inverse of x plus tan inverse of y equals to tan inverse of x plus y by 1 minus x into y. This is the formula. So tan inverse of x plus tan inverse of y, that equals to tan inverse of x plus y by 1 minus xy, that is x plus y by 1 minus x into y. Now tan inverse of take LCM in numerator part. LCM is 3, 4, that is 12. Now, so 3 3 is 9 plus 4 2 is 8 by 12 minus 6 by 12. That equals to tan inverse of 17 by 12 by 6 by 12. Now 12 gets cancelled. Tan inverse of 17 by 6 is the final answer. Now you apply tan inverse of tan theta, that equals to theta. So 17 by 6. This is the answer. Now 19th question is similar to 16th question. So we can do 19th question also. Now next question is 20th question, that equals to sin of pi by 3 minus sin inverse of minus 1 by 2 is equal to multiple choice questions. Solution: sin of pi by 3 minus sin inverse of minus theta. We know the formula. Sin inverse of minus x equals to minus of sin inverse of x. So minus sin inverse of minus 1 by 2 equals to minus of sin inverse of 1 by 2. So already we have minus into minus plus. sin inverse of 1 by 2. That equals to sin of pi by 3 plus sin inverse of 1 by 2. That value is equal to pi by 6. Already we solved this problem in exercise 1. Sin inverse of 1 by 2 value pi by 6. So sin of pi by 3 plus pi by 6. That gives sin of LCM is 6, 2 pi plus pi, 3 pi by 6. Sin of 3 pi by 6. That is sin of 3132 pi by 2. Sin 90. Sin 90 value 1. So the correct option is B. Correct option is B. Next question. That is 21st one. Tan inverse of root 3 minus cot inverse of minus root 3 is equal to solution given tan inverse of root 3 minus cot inverse of minus root 3. We know that cot inverse of minus x equals to pi minus cot inverse of x. So in place of this function you can write pi minus cot inverse of x. Tan inverse of root 3 minus pi minus cot inverse of root 3. That is tan inverse of root 3 minus pi plus cot inverse of root 3. Next, tan inverse of root 3 minus pi. So you convert this cot term in terms of tan. So tan inverse of 1 by root 3, reciprocal value. Now tan inverse of root 3 plus tan inverse of 1 by root 3 minus pi. Now you apply tan inverse of x plus tan inverse of y. Tan inverse of x plus y by 1 minus x into y minus pi. Since tan inverse of x plus tan inverse of y equals to tan inverse of x plus y by 1 minus x into y. So that equals to tan inverse of root 3 plus 1 by root 3 by root 3 gets cancelled. Remaining term is 1 minus 1 into minus pi. So that equals to tan inverse of root 3 plus 1 by root 3 by 1 minus 1, 0, something by 0, infinite. Tan inverse of infinite minus pi. In tan function, at what degree will get the value infinite? Tan 90 infinite. So infinite, in place of infinite you can write tan 90. That is tan inverse of tan 90. That equals to infinite. Tan 90 infinite. Infinite value tan 90. Minus pi minus pi. So tan inverse of tan theta, that gives theta. Pi by 2 minus pi. Next, half minus 1, half minus half, that is 5. Minus 5 by 2 is the answer, that is option B. Option B is the correct answer.